Now the problem with some questions is that we might take what at first seems like a perfectly reasonable question, 51.25 divided by 7. Perhaps that's something with context. It could be £51.25 shared among 7 people. It might not be, it might just be a question. But we take what seems like a perfectly reasonable question and we get a perfectly reasonable answer, 7.321428571. And that's a slightly mucky decimal. Nothing wrong with it as an answer, it is a number. But a decimal that's that long, that has that many things after the decimal point, isn't that useful to us. It's quite difficult to picture that as a number. It's quite difficult to conceptualize that into something we can think about. The 7 is okay. Even the 7.3 and possibly even the 7.32 seems reasonable. But all that stuff afterwards, it's quite difficult to picture because it's just too much information. It's more information than we could ever really need for any given context. Now we've seen with these estimating questions that actually we can use close approximations to find rough answers. But maybe we could take that idea and turn this into something a bit more useful, a bit of a firmer concept, something we can use every time with a certain set of rules, turn it into an actual proper mathematical thing to give us useful answers to questions where we get stuff like this, stuff that's true and factually correct, but not that useful. And this is where an idea called rounding comes in. Now, rounding is quite similar to estimating. Estimating is us using our gut feeling, using instinct to give us approximate answers. Rounding is a little bit more rigorous, a little bit more structured than that. But rounding is us saying this answer that's quite long or a bit messy, well, it's roughly close to, and then depending on a certain degree of accuracy, depends what we want to give it to. We need to round to different, what's called degrees of accuracy. I'll explain as we go along what they are. Well, the first one we're going to look at is we're going to have a look at rounding to the nearest 10. Now the nice thing about rounding is that whatever you are rounding to, whichever degree of accuracy you are using, in this case nearest 10, whichever one you are using, the skill is the same. We just adapt it for the different numbers and different focuses. So I've got part of the hundreds, tens and units grid here. Thousands, hundreds, tens, units. And the first one I'm going to round 31 to the nearest 10. So I'm going to put 31 in my grid, and there it goes. 3 in the tens and 1 in the units, 31. Now I'm rounding to the nearest 10. So imagine I counted up in tens. I would go 10, 20, 30, 40. And this number 31 clearly falls between 30 and 40. Slightly better way of looking at it. If we're going to the nearest 10, this is the number that we're focusing on, the tens number. Now that tens number is either going to stay as a 3 tens and be a 30. Or that tens number might change. It might increase to a 4 and become a 4 tens or 40. Notice that they are the two numbers that 31 falls between, 30 and 40, the two tens numbers. Now what I'm going to do, I'm going to the nearest 10, I'm going to put a splitting line in there. Because this line splits from what we are focusing on to give us the tens numbers and what's going to tell us which of them it's closest to, because that's the whole idea with rounding. It's saying, well, if we're rounding to the nearest 10, which tens numbers is it between and which one is it closest to, and the one it's closest to is the one we're going to round it to. Which one is that closest to? Well, clearly 31 is closer to the 30. It is a 1 afterwards. That 1 is clearly much closer to the 30 than it is to the 40. So 31 rounded to the nearest 10 is 30. Round 48 to the nearest 10. So we're going to the nearest 10 again, so I'm going to put my split line in after the tens number. This tens number here, the 4 tens, is either going to stay as a 4 tens and be a 40, or it's going to increase by 1 and become a 5 tens, i.e. 50. And notice that if I count it up in tens, 10, 20, 30, 40, 50, 40 and 50 are the two tens numbers that fall either side of the 48. To see which one of those it's closest to, I'm going to look at the first number after that split line, i.e. the units one here. That number is an 8. It being a 48 pushes it closer to the 50. It is clearly much closer to the 50 than it is to the 40. So when we round 48 to the nearest 10, we get 50. Round 65 to the nearest 10. Well, same thing again, we're going to the nearest 10, so I'm going to put my split line in after the tens. We're going to the nearest 10, the tens number is the one that's either going to stay as it is or change, so we put the split line in after the tens. That tens number of 6 is either going to stay as a 6 tens and be a 60, or is going to push up to the next one and become a 7 tens or 70. We just need to work out which one it's closest to, but clearly 60 and 70 are the two tens numbers either side of 65. To work out which one it's closest to, we look at the first number after that split line. It is a 5. And it being a 65 means it's entirely in the middle. It's 5 away from 60 and 5 away from 70. Thing is though, this question exists, round 65 to the nearest 10, but if it's right in the middle, how can it be nearer to one or the other? Well, it can't. It is entirely in the middle. Now the thing is, we have a procedure that we follow when we are at this middle value, when we are at that 5 point in the middle of two values. And what we do, whenever we are at that 5 halfway point, we go up to the higher one and we say 70. Why? Honestly, because that's what we do. Because when rounding was invented, let's say by Mr. Rounding, when rounding was invented, this problem came about. This what do we do when we're at that halfway between mark? And just to make sure that everybody did the same thing, Mr. Rounding said, let's round up to the higher one. Let's go up to the one above. For no other reason than because he needed to pick one of them, so he picked the higher one. So we're always going to do the higher one because that's just what we do. So 65 to the nearest 10 is between 60 and 70, and because it's at that halfway point, we go up to the higher one. And this idea with the first digit after that split line, wherever you've put it, is true for any degree of accuracy at all, whether it's nearest 10 or whether it's another one that we're going to come on to. If you are at that 5 halfway point or more, then you round up to the next one. If you are below that 5 halfway point, then you go down to the previous one. Because anything below the 5 halfway point is clearly closer to the smaller one. Anything above the 5 halfway point is clearly closer to the top one. If you are at that 5 halfway point, then just by convention, just because that's what we do, we go up to the higher one. Round 342 to the nearest 10. Okay, so this is a hundreds number this time, but we are still rounding to the nearest 10. The fact that there is a hundreds digit in there doesn't change anything about what we're going to do. We're rounding to the nearest 10, so we put the split line in after the tens number. The tens number is the one that's either going to stay or change. So it is either going to stay as a 4 tens and 40, or it is going to change to be a 5 tens and 50. The problem is though, with rounding, the whole idea is that the answer at the end is similar in size to the one that we started with. We are rounding. It's just about smoothing off those rough edges and giving us a close approximation. And 40 and 50 are not close to 342. But we've forgotten something. We have forgotten that this 300s number is there. That is not going to change. So really, our two tens are 340 and 350. And if you were to count up in tens, you would eventually hit 340 and 350. They are numbers that would be in the 10 times table. To work out which one of those it's closest to, we look at the first digit after that split line. It is a 2. It being a 2 is lower than that 5 halfway point. If it's at the 5 halfway point or more, we would round up to the higher one. If it's less than that 5 halfway point, it must be closer to the lower value, so it must be closer to the 340, and 342 to the nearest 10 is 340. Round 675 to the nearest 100. So we're rounding to the nearest 100 now, rather than the nearest 10. But we can still follow the same steps as before. We're rounding to the nearest 100, so I'm going to put a split line in, not after the 10s this time, but after the hundreds. Nearest 100, split line goes in after the hundreds. This hundreds number is the one that's either going to stay as it is or it's going to change. So it will either stay as it is and be a 600, or it will change to the one above and be a 700, and 600 and 700 are the two hundreds numbers that 675 lies in between. To see which one it is that we are closest to, we look at the first number after that split line, the first digit, and that is a 7. The 7 is more than that 5 halfway point, so it's going to push us up to the higher value, the 700. Notice that we have not used the 5 because it doesn't matter what that is. If that was a 1, it would still push up because the 7 is having a bigger contribution. If that was a 9, it would still push up because the 7 is having a bigger contribution. It doesn't matter what that 5 there is doing in the units. The tens one is the one that matters because that's the first digit after the split line and it's having a bigger overall contribution. But notice that rounding to the nearest 100, very similar skill to rounding to the nearest 10, just with the split line in a different place. This idea of knowing where to put the split line in is important. If you are rounding to the nearest 10, you put the split line after the tens number. Rounding to the nearest 100, the split line goes in after the hundreds number. If you were rounding to the nearest 1000, you could do exactly the same steps as before, just put the split line in after the thousands number. And then everything else follows. Once you've put your split line in, look at the first number after that split line, the first digit there, and that's the one that's going to tell you whether it's pushing down to the smaller value or up to the higher value, according to whether it's at, above, or below that 5 halfway point. Let's take things up a step in difficulty now by bringing some decimals into it and looking at a different way of rounding. This time, we're going to round 2.1 to the nearest whole number. But all the same ideas about rounding still apply. The skill is the same, whatever degree of accuracy we are talking about, degree of accuracy, nearest 10, nearest 100, nearest whole number, etc. The skill is the same, whatever we are rounding to. As long as we know where to put that split line, and we get that in the right place, the rest of it should follow fairly easily. So we're going to the nearest whole number. I.e., we're going to be trying to get rid of the decimal bit. So our split line is going to go in there, in the middle, at that cut point between the units and the tenths. So this units number is either going to stay as a 2 or it's going to push up to the next one and become a 3. To work out which one, we look at the first number after that split line, i.e. the tenths number in this case. The tenth number is a 1, it is smaller than that 5 halfway point, and then our whole thing is going to push down towards the smaller value of 2. And 2.1 to the nearest whole number is 2. Round 16.59 to the nearest whole number. Well, same thing again, we're going to the nearest whole number. So we are splitting off the whole number part and the decimal part, and our split line is going to go there, in the gap between the units and the tenths. The whole number part is the bit that's going to stay or change. So it will either stay as a 16, because we've got to remember that that 1 is there as well, that 10. So it's either going to stay as a 16, or it's going to push up to the next one and be a 17. Notice that the 1 is staying in both cases, the 6 or the 7 that's changed, if it does. To work out whether we change or not, we look at the first number after that split line. The first number after is a 5. The 5 is at that halfway point. If we are at or above the halfway point, we push up to the higher value and we push up to the 17 because 16.59 is closer to the 17 than it is to 16. It is past that halfway point. Notice that we've not used the 9 at all. The 9 is there, but it hasn't played any part in the rounding process because the 5 is a bigger contribution. The 5 is more important to which way we're going than the 9 is. But 16.59 to the nearest whole number is 17. The other degree of accuracy you might have to round to is something called decimal places. You might have to round to 1 decimal place, or 2 decimal places, or possibly 3 decimal places. Rounding to a given number of decimal places is exactly the same steps as rounding to any other degree of accuracy. As long as you know where to put the split line, the rest of the process follows through in exactly the same way. But first of all, what are decimal places? Take these numbers for example. 4.6 is a number given to 1 decimal place. 13.42 is a number given to 2 decimal places, and 56.035 is a number given to 3 decimal places. Decimal places are just the number of digits after the decimal point. So 1 decimal place means we have 1 digit after the decimal point. 2 decimal places means we have 2 digits after the decimal point, and 3 decimal places means we have 3 digits after the decimal point. Doesn't matter what's in front. Decimal places is the number of digits after the decimal point. So if we are asked to round to a certain number of decimal places, we have to shorten the number through this proper rounding process so that we end up with that many digits after the decimal point. So let's have a go at rounding to 1 decimal place first of all. Round 2.14 to 1 decimal place. 1 decimal place means we want to have one number after the decimal point. Well, there is our one number after the decimal point. So our split line goes in after that. Our split line goes in so that when we round, we would only have one number after the decimal point. This one number after the decimal point is the one that's either going to stay as it is, as a 1, or change and move up 1 to become a 2. So it's either going to stay as a 2.1 or it will become a 2.2. Both of those have one number after the decimal point. Both of those are 1 decimal place numbers. We just need to work out which one it's closest to. To work out which one it's closest to, we look at the first digit after that split line, same as we do for any other kind of rounding. The number after the split line is a 4. 4 is less than that 5 halfway point, and if it's less than that 5 halfway point, it's going to drag down to the smaller one, and 2.14 correct to 1 decimal place is 2.1. Round 3.49 to 1 decimal place. Same idea again, we want one number after the decimal point. And there goes our split line, at the point where we change from having 1 to having 2. This number here is the one that's either going to stay or change. So we're either going to stay at a 3.4 or we're going to move up to be a 3.5. The 9 after that split line is the one that's going to tell us whether we stay or change. It is a 9, it's more than that 5 halfway point, so it's going to push up to the higher one and become 3.5. And 3.49 rounded to 1 decimal place is 3.5. Round 10.97 to 1 decimal place. Well, same thing again, we're going to 1 decimal place, so we're going to put the split line in after that. There's our 1 decimal place, and there goes the split line. This one here, this 9, is the one that's either going to stay as it is or it's going to change. So it will either stay as a 10.9 or it will increase by 1 and push up to be, ooh, what will it push up to be? Well, 10.9, next one up, would actually be 11, but we need 1 decimal place, 11.0. Now that's okay, it looks weird. And normally we wouldn't bother writing the 0.0, but if that turns out to be the answer, that's okay, because we are specifically requiring 1 decimal place, one number after the decimal point, and if that number happens to be 0, then it happens to be 0. That's absolutely fine. 10.9 could stay as that, or it might push up to be an 11. To work out which one of those it's going to be, we look at the first number after that split line. The first number after that split line is a 7. 7 is more than that 5 halfway point, and if it's more than that 5 halfway point, it's going to push up to the larger of the two. It's going to push up to the 11.0, and again, looks a bit weird, but it is fine. It has 1 decimal place, just that that decimal place happens to be a 0. And finally, round 9.134 to 2 decimal places. Well, once we've worked out where to put that split line, as with any other rounding question, we can just follow the normal steps until we've rounded to the answer. That split line, we want 2 decimal places, so we want 2 numbers after the decimal point. There is the decimal point, so 1, 2, and our split line goes in after that. This 3 here is the only number that is going to change, if anything does, unless of course the whole thing pushes up into the next number. In this case it isn't going to though, so it's either going to stay as a 9.13 or the 3 will change to be a 9.14. We just need to work out which one of those it's closest to, and to do that we look at the first thing after the split line, which is a 4 here. The 4 is less than that 5 halfway point, and if we are less than the 5 halfway point, we're going to pull down towards the lower of the 2 values, i.e. the 9.13. And 9.134, correct to 2 decimal places, is 9.13. There are exactly 3 times when you might round an answer. The first time you might round an answer, if the question specifically tells you to. A question might say, work out the answer to this problem and give your answer correct to 2 decimal places. In which case you would work out the answer and write that down in full, and then round it to 2 decimal places. And there will be a mark available for doing that, a mark that you won't get if you don't do it. The second time you might round is if you get a long, complicated answer that's got lots of decimal places and it just doesn't make much sense, perhaps because of the context of the question, perhaps because it's just too big to work with. In which case you can round, but only round at the end of the question and specify what you've rounded it to. If you have rounded it to 2 decimal places, then write down that you have rounded it to 2 decimal places. If you've rounded it to 1, then write down that you've rounded it to 1. But do this sparingly, please, because you don't want to get the answer wrong because you've rounded it incorrectly. The third time you might want to round is if you are dealing with money. For example, that might come out as the answer from a calculator. That clearly does not look right. We only want 2 decimal places for money, so we would be rounding to 2 decimal places and we will be giving our answer as either 4.59 or 4.60, in which case it's going to come out, because of that 2 there, as the £4.59. And we've chosen to round because it's money, because the context means that we have to. In particular though, do not just round all over the place, do not round in the middle of questions, save it till the end, keep the larger answers as you're going through your working, and don't just round for the sake of it. Definitely don't round in the middle of questions for no reason at all. Decimals are fine, they exist, we can work with them. I know that they're not nice, but they are fine. So 3 reasons to round: if the question tells you to, if the answer is so long that it would be better to round because it's more workable, more usable, or if you're dealing with money. Any other occasions, do not round.